lovely viewers. Good evening and welcome to Eugene TV. Let's take a look at this question. This question is simply based on GAY-LUSSAC'S law of combining volume. And the question reads, 100 cm cube of hydrogen were mixed and sparked with 100 cm cube of oxygen gas at 110 degrees Celsius. What is the total volume of the residual gases after sparking? I have the following option here, option A to E. Please, if you know the answer, please drop the answers in the comment section. Alright? Okay. Before we go into solving this problem, let's take a look at the GAY-LUSSAC'S law. GAY-LUSSAC'S law is one of the gas laws used in describing the behavior of gases. And GAY-LUSSAC'S law simply states that at constant temperature and pressure, when gases combine, they do so in volume, which bears simple ratio to one another and to the volume of the product if gaseous. Okay? So I'll take that again. That GAY-LUSSAC'S law says that in as much as temperature and pressure are kept constant, when gases combine, they do so in volume, which bears simple ratio to one another and to the volume of the product if gaseous. And of course, one good thing about this law is that it enables us to convert the number of moles of gases to volume. Alright, so there are two things that we can do if we want to solve problem on GAY-LUSSAC'S law. Or there are two things we need to understand very well. Number one, we should be able, or we must be able to write a balanced chemical equation between the reacting substances there. Alright, that's number one. And then number two, we must take note of the temperature of the reaction mixture. We must take note of the temperature of the reaction mixture. Okay, come closer as we begin the journey. Okay, so if we say hydrogen were sparked with oxygen, that simply means that hydrogen gas were reacted with oxygen gas. And of course, when hydrogen combined with oxygen, we will produce water. Or let's say we will produce steam, depending on the temperature. Because the temperature is above 100 degrees Celsius, so water is going to be in form of water vapor. Alright, so let us balance the equation first. Let us put 2 here, meaning that 4 hydrogen, and then we'll put 2 here, meaning that 4 hydrogen. So the equation is balanced now. The equation is balanced. Okay, let us establish the mole ratio. So for the purpose of our calculation here or study, we will use MR to represent mole ratio. The mole ratio here is 2 is to 1 is to 2. And this simply means that the ratio in which hydrogen combined with oxygen to produce steam is 2 is to 1 is to 2. And of course, mole ratio simply means that the ratio of the coefficient of reactant and product in a balanced chemical equation. The ratio of the coefficient of reactant and product as it appears to be in a balanced chemical equation. Alright? So the next thing is that we are going to take volume before. The volume the examiner brought before. The question tells us that 100 cm cube of hydrogen, meaning that he brought 100 cm cube of hydrogen. And then when mixed and sparked with 100 cm cube of oxygen, that simply means that he also brought 100 cm cube of oxygen. Now, before the reaction, nothing will be produced here. Remember, this is before the reaction will take place. Alright? This before the reaction will take place. Okay. From the balanced chemical equation, it means that if you have 2 cm cube of hydrogen, we will require 1 cm cube of oxygen. So it also followed us that if you have 100 cm cube of oxygen, we should require 50 cm cube. Since if we have 2 here, we need half of 2, which is 1. So if you have 100 here, we need half of 100. But in this case, we are giving more than 100. So it will mean, so we are giving up to 100. It means that it is not all the 100 cm cube of oxygen that will react. It is going to be 50 cm cube. Okay, let us look at volume after. Volume after. So if this person actually brought 100 cm cube, from our mole ratio here, it means that it is only 50 cm cube of this gas that will react. Why? Because when we have 2 here, we need 1. So if you have 100 here, we need half of 100, which is 50. Even the equation gave us up to 100 cm cube. It is not going to be all the 100 cm cube that will actually react. Alright? So let us also establish the volume of the product here. Remember, from the balance equation here, if we have 2 here, we can end up producing 2. What if we have up to 100 here? How many can we produce here? If we don't know, if we are not sure, we can relate it this way. If we have 2, we need 2. And now that we have 100, what do we need? We don't know. We call it X. So if we make x such a formula and we cross multiply, we'll say x is equal to 100 times 2 all over 2. Of course, we know that 100 times 2 is 200, and 200 divided by 2 is going to give us 100. So that simply means that if we have 2 here, we can produce 2, and if we have 100 here, we can end up producing 100 cm cube of steam. We'll end up producing 100 cm cube of steam. Let me put up this. Alright, so if you have 2 here, we can produce 2. So if we bring 100, we can produce 100. Now let us check the volume after the reaction is complete. Volume after sparking. Okay? So the volume after sparking is going to be determined thus. At the end, 100 cm cube minus 100 cm cube, it will be 0 cm cube. It means that all the 100 cm cube that was brought will be completely reacted. Okay, let us go to this side. 100 cm cube minus 50 cm cube, we are going to have 50 cm cube as leftover. This gas or this volume is going to be excess volume or unreacted volume of oxygen gas. Alright? So the question now say, what is the total volume of the residual gas? So if we want to determine the total volume, let's say the total volume of residual gases is going to be, residual gases simply means at the end of the reaction, what are the gases that will remain there? Remember, in that container, we are going to have the volume of the product here, and also the excess volume, the unreacted volume that refused to react. So everything will just be in the container as a kind of residue. Alright? So the total volume of residual gas is going to be determined by summing up volume of product, which is 100 cm cube, and volume of excess gas, volume of unreacted, let me put this that way, unreacted gas. So in that case, we are going to, volume of the product, we are calculated to give us 100 cm cube, and then volume of the excess gas is calculated to be 50 cm cube. So at the end, our total volume of residual gas is going to be 150 cm cube. 150 cm cube. So from our explanation and calculation, our correct option is option letter D. Our correct option is option letter D. Please, if you have problem on how to find or calculate or some problem leading to GAY-LUSSAC'S, please give me a DM. Give me a message in my DM, and do well to follow my YouTube channel, Eugene TV. You can also follow me on TikTok, Eugene TV 101, for more video. I have uploaded a lot of videos that cover gas laws. And if you have any problems specifically on any gas law, please just give me a DM and I'll answer you. Thank you and bye.